Okay, shall we start? Data organizing we discuss. And you identify different terms with value, class, form, real limits, practical limits, mathematical limits, all things. Then we want to present this data. That is our third functions of a statistic, presentation of data. Therefore, we take main heading, data presentation. Data presentation. Data presentation. That is to other side, no? Very strange. We know how to change that. That is as a mirror. Because we are using so this A. Okay, I will call it. Oh, depends. Maksudnya kayak jangan. Sebenarnya itu kata itu bang itu katanya masuk perbedaan. Itu orang yang pernah dinaruh tidak tidak ini kakak dinaruh mau lain. Right, we start data presentation, but you can see as a mirror. But anyhow, it will be changed by the ID. Right, data presentation means the graphical presentation. We want to discuss graphical presentation. You know pie charts, bar charts, those simple charts, but very quickly we want to finish histogram, frequency polygon, frequency curve, and ogive. Ogive means cumulative frequency curve. These graphical presentations. Right, you can write down like this. Data presentation represents data presentation represents the graphical presentations. The graphical presentations. Graphical presentations. It comprises following graphical presentations. Following graphical presentations. Right, first one, histogram. Histogram. That is other side, right? Histogram. 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 Second one, frequency polygon. Frequency polygon. Right on lines, it will be addressed very quickly. Frequency polygon. Third one, frequency curve. Frequency curve. Fourth one, cumulative frequency curve. Cumulative frequency curve. Cumulative frequency curve. Otherwise, it is called ogive. 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 Right, these presentations you want to learn histogram, frequency polygon, frequency curve. We can construct all these graphical presentation in one graph, right? One. Therefore, we take heading, subheading, histogram, frequency polygon, and frequency curve. So same graphical presentation we use. Right. Now we want to construct histogram, frequency polygon, and frequency curve. Right. What is meant by histogram? Histogram means in the x-axis you can take mid value or real limits. Mid value or real limits. Y-axis you take frequency. Frequency of each mid value or real limit is represented by a rectangle. That is a bar. All the rectangles should be linked together. Why? Area covered by the rectangle is important. The probability is calculated later by using area. Therefore, in the histograms, all the rectangles should be linked together and you need to consider the scale. If you take the same scale, you have to use the ruler and take the same scale because area enclosed by histogram will be equal, will be important. Then to construct this frequency polygon, we take mid value. We keep one scale free, then mid value of all these rectangles you can link with linear line. That is called frequency polygon. If you link all these mid values by using it smoothly without linear line, freehand, when you construct, that is called frequency curve. area covered by histogram, frequency polygon and frequency curve will be approximately equal. They are equal. That's why we calculate probability by using area in normal probability distribution. Normal probability distribution. It is coming with histogram. Normal probability distribution is a hypothetical distribution, symmetrical distribution. Later you will study fully, but you need to understand it is coming from histogram. Clear? Right. Now we want to write down like this. In the x-axis, we consider mid value or real limits. Mid value or real limits. In the y-axis, frequency is presented. Frequency of each class is presented by a rectangle. Rectangle or bar. Within that bar. A rectangle. Bar. Stamp. By bar. All the rectangles should be linked. Together. This is because area covered by the rectangle. Is important. Therefore, scale. Therefore, scale should be considered correctly. If the mid values of all rectangles, all the rectangles are linked by using linear lines, straight lines, that is called frequency polygon. If the mid values are linked, smoothly, there is a curve, right? Smoothly. That is called frequency curve. Sometimes we say smooth frequency curve. Smooth, because it's smoothly we construct. Area covered by histogram, frequency polygon, and frequency curve will be equal. Normal distribution is obtained from histogram. That is a hypothetical distribution. That is a hypothetical distribution. That is a hypothetical distribution. Right, now we want to construct right. Yeah. Okay. You organize the data set. Group frequency distribution you organize. Right, to that organized group frequency distribution, we can construct this. Right, give me that you are having class and the frequency. You obtain 2029 like that. Up to 80s, no? 30, 39, 40, 49, 50, 59, 60, 69, 70, 79, 80, 89. For this data set, we organize this data set. Right, for this data set. Right, what is the frequency we obtain? First one, 3, 5,
6, 5, 4.
right, we had 40 observation, no? Right, 40. Right. For this organized group frequency distribution, we can construct histogram, frequency polygon, frequency curve, all things. Right, now we start. Take x-axis. To the x-axis, I take x-axis. You can use mid value, otherwise real limit, no problem. One of these two you can take. Decide frequency. Maximum 10, you can decide the scale. No need to construct very large graphical presentation or very small. Moderate level construct. Right, I take 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Take the scale, you can take better. Can use a ruler. Right, then one scale free, because to construct frequency polygon and frequency curve, keep one scale free, then start. 1, 2, 3, 4, 5, 6, 7. Right. 1, 2, 3, 4, 5, 6, 7. Take scale correctly. Same distance. Again, keep one scale free at the end. When you construct histogram, keep one scale free at the beginning and at the end. I take mid value. 2029 mid value 24.5. Then 34.5. 44.5, 54.5, 64.5, 74.5, 84.5. Then what is scale 3? Right here, 2029, height 3, but we consider that is scale as well, therefore 3. Rectangle you can construct. Rectangle, will you go as well? That's about. Next one, 30, 39, 5, approximately here. Then 40, 49, 7. Fifty, 59, 10. Then 6. 70, 79, 5. 88, 9, 4. That is histogram. Histogram. ज़्यादा rate है histogram. Right, and this is big change by IT support. But anybody knows how to change this mirror to the other side? You know? Right, I think that they have to inform it, but maybe a little bit delay. Right, so this is histogram. In that histogram, you can see this is the tallest one. It is called mode class. Mode class. The tallest class, highest class is the mode class. Martha Panthea, mode class. Now, if you want to the mode class, you can see left side, one rectangle is length. From that to straight line, you take to right side corner. this point. Again, from the forward, you can see another rectangle is linked from here. From that to left side corner, another straight line you construct. These two. Then you can see there is an intersection point. From that intersection point, you take a perpendicular line to the x-axis. Perpendicular line. Lambda. So then it represents mode value. This is called mode. Mode class. This is the mode. 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 Okay, now all the center points you can link linearize. Right. By using ruler O, you can put all the midpoints. You can mark. And just you can net the appearance, you can do mid values. All the mid values of rectangles you can link. Then at the beginning, one scale free, then take that row. And also at the end, take that. Right. I don't remember. Yeah, okay. Right. It's okay. Right. They can see correctly. Right. Then all these midpoints you can link linearize. Linearize. This is called frequency polygon. Frequency polygon. Frequency polygon. संख्यात्मक बहुआश्रय. Frequency polygon. Linear lines, straight lines. Therefore, you have to use a ruler. Using ruler. And use a ruler. If not ruler, use your ID card. In your linear lines. Now see area. This is additionally taken by frequency polygon. Therefore, same portion has been cut from the histogram. Again, additionally, this area has been taken by the frequency polygon. Same portion has been removed. Then what happened? Area covered by histogram and frequency polygon will be equal. Right, then all these midpoints, not linear line. You know, the graphical presentation you have done like this, right? Like that you can mark. There may be ups and downs slightly. Little bit change there may be, but smoothly you construct. That is called frequency curve. Frequency curve. Frequency curve. Some ups and downs here maybe. No problem. Your graphical presentation is more accurate than me because I did not consider the scale. Right, area covered by all these will be equal. But because of the graphical presentation, little bit may be changed, therefore may be slightly changed, but approximately equal. Right, that is histogram frequency polygon and frequency curve. Later, hypothetical distribution you identify from this, like, but now don't construct in your graph. That is the bell-shaped distribution. It is normal distribution. Later we take that normal distribution, but now at the moment don't construct. Right. When we start normal distribution, you can learn better with attributes of normal distribution. There are some characteristics. Right, now, then we want to start argue, right? Then take argue or cumulative frequency curve. Cumulative frequency curve. Argue for cumulative frequency curve. In the x-axis, take mid value. X-axis take mid value. Y-axis take cumulative frequency. The cumulative frequency is represented by each mid value, then you link as a curve, like that you can see. Or sometimes it will be on the other side, but cumulative frequency, you take cumulative frequency. In the right side, if you expect, you can present percentage cumulative frequency to identify percentage value. You need on, otherwise only cumulative frequency is enough. Right, first write down like this. In x-axis, we consider mid value. We consider mid value. In y-axis, cumulative frequency is presented. Cumulative frequency is presented. Cumulative frequency of each mid value is presented as a curve. That is called argue. If we need percentage, cumulative frequency, that can be presented in the right side y-axis. the right side y-axis. Okay, let's practice. Now take that class. Additionally, I take cumulative frequency. Here. You know 3, when you add this 5, 8, this 7, 15, 10, 25, 31, 36, 40. That is my cumulative frequency. Okay, now take x-axis mid value. Like in histogram, no need to keep scale free. You can start from the beginning. Right, 1, 2, 3, 4, 5, 6, 7. I take 1, 2, 3, 4, 5, 6, 7. No need scale free. Right, then I mark mid value 24.5, 34.5, 44.5, 54.5, 64.5, 74.5, 84.5. Sometimes if you are not starting 0, you are using zigzag line like this. If you want, you can use no problem. Right, then here I take cumulative frequency. 40. If it is from 5 to 5, you can decide 5, 10, 15, 20, 25, 30, 35, 40. Right, from midpoint I mark midpoint 3. Approximately you can take 3 here. Next mid value 8. Then after this, then 15. Then 50, 59, 25. Then 31. 31. 36. Then 40. Right, then marks as a curve. Mark as a curve. That's it. Right, then from root point, or if you use a zigzag line from there, after that zigzag line, you can start no problem. Not linear line, smoothly link. This way. Don't use ruler. This is Augur or cumulative frequency curve. Augur. Or cumulative frequency curve. Right, now suppose you are having 40. Therefore, from 40 you can take this line. If you have 42, take from 42. Even though you have used here 50, don't take from 50. Total 40. Therefore, from that 40, if you take a line here, so the y-axis also, y-axis, right side y-axis, you can see like this. Right, then this is percentage cumulative frequency. If the total 40, from 40 you can take. If the total is 38, from 38 take that line. Then that is the 100%. Because out of 40, 40 means 100%. Then I can take this is 100%. By using ruler, you divide 2, 50%. Half of this 75%. Half of this 25%. Like that, if you want, you can present percentage cumulative frequency. It is not compulsory. If you want, you can present like this. Percentage cumulative frequency. If you need only. Because the graph up to this, if you want to leave, it is coming here. Because out of 40, 40 means 100%. This is cumulative frequency curve. Okay, then understand another important thing. I mark this one. Median. Median. I want to design. Median is similar to second quartile. Second quartile. Second quartile is Q2. Right. N divided by 2, you can decide. N over 2. Median means when you take your data set, the middle point value of the data set. After you organize in ascending or descending order. Later we calculate all these, right? By using formulae, we can calculate. N means how much? 40. 40 divided by 2, 20th observation is the median, right? This is median. Location of median. Location of median. Or second quartile. N over 2, 40 over 2, 20th. Right, from 20th, you can take a line. That is parallel to x-axis, take a linear line. Right, from that to take here, this is called median. Median. Data set can be divided equally. Median. Slightly changes may be according to a graphical presentation, but when you are calculating, all of you will take same answer. Same answer. That is second quartile low, median. Right, if it is, you can decide Q1, that is first quartile location. First quartile location also you can decide Q1. Q1 location, that is first quartile location. How you decide? N over 4 multiplied by 1. N means 40 divided by 4 multiplied by 1. That is 10th one. 10th one. Right, now construct from 10. here. N. Then you are coming to this is your first quartile, Q1. Q1, first quartile. Right, this is second quartile or median. Then calculate third quartile, Q3 location. Q3, that is third quartile. Third quartile location. Right, n over 4 multiplied by 3. Multiplied by 3. 40 divided by 4 multiplied by 3, answer 10 30th. 30th. Right, from 30th you take again. This. This is your Q3, third quartile. Third quartile. Okay, now you identify first quartile, median is second quartile, and third quartile. Right, this difference if you take Q3 minus Q1 difference, that is called interquartile range. Interquartile range. Interquartile range. IQR. Interquartile range. Q3 minus Q1 difference. Right, if you want to divide your customer base equally into 4 parts, first part, second part, then third part. From 3 points, 1, 2, 3, like that. Otherwise, your customer, right, first quartile, second quartile, third quartile, you can divide entire customer, middle point, second quartile, then this part, first quartile, this one, third quartile, like this. Okay. From first one, this one, then second one, another part, third one, then up. You can see like this. That is Q3. That is Q3. This is Q1. This is Q2. Then you can see this part, this part, this part, like that. You can divide. Later we calculate. Okay. Now graphically understand, slightly changes may be from person to person according to a graph. Right, these are the things you want to understand in graphical presentation. You know bar charts, pie charts, those are very simple charts. We don't want to discuss them here. Later, I think that in this exercise, you can practice this exercise graphical presentation. Right, practice this one to construct later. Right, to start our calculation part. Now, so far we have discussed collection of data. We finished from sampling method, right? Random sampling, non-random sampling. Then data organizing. After that, we learn different terms. This is data presentation, graphical presentation. Then we need to start analysis. When we identify or when we start analysis, at the same time, you have to interpret the results and take decisions. Conclusion, taking reasonable decision, all these together with the analysis. To start the analysis, you should have the knowledge of sigma. Without that Greek letter sigma, you can't start analysis. Therefore, we take again main heading sigma notation. Sigma notation. Sigma notation. Or sigma symbols. Sigma notation. When you take sigma, two types of sigma, Greek letter. Capital sigma. Simple sigma. I think you are aware. Okay? Right. This is capital sigma. This is simple sigma. Okay? You know theta, simple theta, capital theta, Greek letters. But no need theta here. Right, then sigma, as the sigma notation, we want to study this capital sigma. Rules. Some rules, there are some rules. If you are violating these rules, you can't do correct calculations. You are doing many mistakes because you do not know the sigma rules. That is the problem in statistics. Without understanding sigma notation, that capital sigma rules, you can't do calculation correct. Right? That's the problem. Right. Now we write down like this. Sigma symbols can be classified. Simple sigma can be classified as capital sigma and simple sigma. Capital sigma and simple sigma. They are given below. They are given below. Right. Capital sigma, simple sigma. Let's do. Right. As a sigma notation, we want to consider here capital sigma. This is standard deviation. Later you calculate in measure of dispersal, you calculate capital simple sigma. This one we want to learn. Right. Now further write down. Here we consider capital sigma. Capital sigma. It represents summation of observations. It represents summation of observations. Summation of observations. Nirikshitawala ekatva. Right? It is represented by summation of observation. Nirikshitawala ekatva. As an example, sigma I equals 1 to n xi. Sigma I equals 1 to n xi. What is meant by this? This means that you want to start from this point 1, I equals 1, x1, x2, x3, like that to the last one, n, x, n. What is this capital sigma plus summation? This expansion can be written briefly by using sigma notation. Sigma I equals 1 to n xi indicates this expansion. This is expansion. Expansion. Prasar method. This is in short form, brief or short. Short form. Short form. In formula, you can see sigma x. And I equals 1 to n xi, like that you cannot see sigma x means this one. Normally, this is represented by sigma x. This expansion we can't use in formula. We have to directly write. If you have thousands of observations, how you can write thousands? Therefore, in brief, we are writing. Okay, using this knowledge, expand this one. Sigma I equals 1 to n. I take 1 to 5. 1 to 5, right? X I. Right, expand this. X1, X2, X3, X4, X5. That expands. Right, now do this one. Sigma I equals 2 to 6, 1 over Xi. 1 over Xi. One over X2 plus 1 over X3, 1 over X4, 1 over X5, 1 over X6. That expands. This one. Sigma j equals 3 to 6, right? X squared j. Now practice. X 3 squared plus X 4 squared, X 5 squared, X 6 squared. That expansion. Okay, like that we can write. But many times we can see mistakes are done by you without understanding sigma rules. Therefore, practice 5 rules. If you practice these 5 rules, you are not doing any mistakes. You can simplify models, you can simplify equations, you can develop models. Right, then we take subheading sigma rules. Sigma rules. sigma rules. Okay, when you are developing models, because in regression models, finally we want to develop the models. When we develop these models, sigma should be correctly applied. And if you are simplifying the models, simplifying the formula, you want to use correctly sigma rules. Otherwise, many times mistakes. Mistakes means wrong calculation, wrong interpretation, and you cannot take outcome. Right. Therefore, please write down. If we correctly apply sigma rules, we can develop models. And we can simplify formulas. Right, rule one. Right now, I write like this. If I take C, it's a constant, right? Constant. And no need to write down now. C is a constant. It is a fixed value. Suppose that 2, it is fixed. Then variable, different values. Variables. We learn, right? Variable. Suppose X. Y also maybe 2, 3, 1, 2, 4, like that, different values. Y also may be different values. 3, 2, 2, and 4, 1, different values. Then rule 1 says, if a variable is multiplied by a constant and take the summation, that value is similar to summation of the variable multiplied by constant. Understood? If a variable is multiplied by a constant and take the summation, that value is similar to summation of the variable multiplied by constant. You still couldn't understand. I understood that you couldn't understand. Isn't it? I write notation. If a variable is multiplied by a constant, the constant variable xi multiplied by a constant, take the summation. I equals 1 n. Variable is multiplied by a constant and take the summation. Similar to equal summation of the variable I equals 1 to n xi multiplied by constant. See. Therefore, this is equal. Even though you are having sigma cx, that value is equal c sigma x. We can justify, we can prove. Variable is multiplied by a constant, take summation. That value is similar to summation of the variable multiplied by constant. That's why sigma you apply to the variable. No need to apply to the constant. Always in models, sigma is applied to variable x, y, z, like that variable, not to a constant. Practice clearly. We want to apply this in models, correlation and regression models. You want to correctly apply these sigma notation. Many times you are doing mistakes and wrong calculation without understanding this. Sigma Cx, sometimes you think that C sigma is different. No, not different. Both are equal. Sometimes the people are writing models by using this way, but when you apply sigma, you can take this constant out because this is the coefficient now. Coefficients. Sangulakya. Understood? Right. Then we write down. Whole one. If a variable is multiplied, by a constant, and take the summation, that value is similar to summation of the variable multiplied by constant. But in wording, if you are unable to understand from this, you can understand. Therefore, write down this one. Forget about this I. Sigma Cx equals C sigma x. And sigma equals 1 to n Cxi equals C sigma equals 1 to n xi. Right. All these you can learn by practicing. Calculate the left side. Sigma I equals 1 to n Cxi. Now practice. This means that before applying sigma summation, you want to multiply by constant. Constant 2, x variable, first one, because first one, 2. Constant 2, second variable, 3. An observation. Third, 2 into 1. Fourth, 2 into 2. Fifth, 2 into 4. Multiply. Then this sigma, red color, I mark, it is plus. Summation. Okay, then take the total 4, 6, 2, 4, 8. 2 into 2, 4, 6, 2, 4, 8. Now take the answer. 8, 10, 20, 24. 24. Now practice the right side value. Right side. 3 sigma I equals 1 to n xi. C is the constant. First take summation. Then multiply. 2 plus, 3 plus, 1 plus, 2 plus, 4. Right, then constant 2, 4, 6, 7, 10, 12. 2 into 12, 24. 24 equals 24. So then you can see that is okay. If you have to multiply by a constant, the variable is multiplied by a constant and then take the summation, that is similar to summation, first summation of the variable, answer multiplied by constant. That is it. You can take the answer. That is rule 1. Clearly practice these rules then you are not doing any mistake. You can understand how it can be addressed. Models can be developed, right? Formula can be simplified, right? Then rule 2, second rule, rule 2. Right, second rule, it says like this. I did this. Right, second rule. This said, if you are taking summation of a constant n times, answer is similar to constant multiplied by n. Summation of a constant n times, constant. Summation of a constant n times. Similar to constant multiplied by n. How many times the constant you add? Similar to constant multiplied by n. Example, constant 5. You add 100 times. 500 times you add 500. If you are adding 100 times, constant can be multiplied by 100. Very simple. That is the second rule. All these rules are coming later. Therefore, you want to practice. Models we develop. I develop by using OLS model, classical linear regression model. When we develop, I take all these sigma notations later. Then we write rule 2. If we take the summation of a constant, if we take the summation of a constant n times, n times, n times, the value is similar to the value is similar to the value is similar to the constant. The value is similar to the constant multiplied by n, multiplied by n. Then you can note down this one. I equals 1 to LCI equals S. NC. Now practice this one. Sigma I equals 1 to N. Instead of N, you can take how many times? 1, 2, 3, 4, 5, 8. There are 5 times we take. I equals 1 to 5 times Ci. If it is 2, second 2, third 2, next one 2, next one 2. 2 5 times. Instead of that, I can use NC. N is 5, C is 2, 10 equals 10. So it can be satisfied. That's why in formula, instead of sigma C, we use NC. NC. In regression model development, we consider this formula. Right? These rules we want to consider. Sigma C, when you apply sigma to the model, you apply A, not sigma. That is rule 2. Then we want to study rule 3, part 1. Rule 3, part 1. Rule 3, part 1, addition. Addition. Second one, subtraction. First one, addition. Right. It says that variable and constant you add. You add. Right. Suppose summation of the addition of variable and constant. Similar to addition of the summation of variable and constant separately. Sigma equals 1 to n xi plus ci. Summation of the addition of variable and constant. That is similar to what? Sigma I equals 1 to n xi plus sigma I equals 1 to n ci. Addition of the summation of variable and constant separately. What this person says, you think? Really understand. Okay, right. First write down like this. Summation of the addition of variable and constant. Variable and constant. Summation of the addition of variable and constant is similar to addition of the summation variable and constant separate. Variable and constant separately. Yes, summation means sigma, right? Now see like this. Sigma I equals 1 to n xi plus ci. Summation of the addition of variable and constant is similar, but sigma I equals 1 to n xi plus sigma I equals 1 to n ci. Here, summation of the addition, the addition of the summation. Now, second rule, if you want, you can use sigma equals 1 to NCI means NC. Instead of this part, you can use NC as well. Clear? Sigma equals 1 to NCI means NC. Second rule, if you want, you can apply. This is the addition rule. Addition, subtraction separately you can do, no problem. Same answer you can find. Okay, we can practice this one. This side. Sigma I equals 1 to n xi plus ci. X2 constant 2. X3 constant 2. X1 constant 2. X2 constant 2. X4 constant 2. I added. Then I use this sigma notation. To understand, I use this sigma plus. Now answer 4 plus 5 plus 3 plus 4 plus 6. 6, 10, 30, 80, 22. 20. Okay. Okay, now next. Right. Next, sigma equals 1 to n xi. Take that answer. I write here. Sigma equals 1 to n xi. Xi means you take the summation of x. 2 plus, 3 plus, 1 plus, 2 plus, 4. 4, 6, 7, 10, 12. Then sigma I equals 1 to n ci. That is equal to nc. How many times? 5 times c to 10. When you take the summation again to it, then no problem addition. Separately you can do. Separately. First you take the summation addition, then summation. Sigma. Separately summation, then add same marks. Same marks. Addition, no problem. That is rule 3, part 1. Then we want to study part 2. Part 2. Part 2. That is subtract. Subtract. Subtraction. But subtraction also same thing. That is the message. Okay. Right, then subtraction separately you can do. Here subtract. If it is here also you can do. Okay. Subtract. Separately you can do. Right, then we write rule 3. Summation of the subtraction of variable and constant. Variable and constant. Summation of the subtraction of variable and constant is similar to subtraction of the summation of variable and constant separately. Variable and constant separately. Variable and constant separation. Right, then write down this part. Separately, you can do that. Right, let's practice. Sigma I equals 1 to n xi minus ci. X2 constant subtract 2, x3 subtract 2, x1 subtract 2, x2 subtract 2, x4 subtract 0, 3 minus 2, 1, 1 minus 2 minus 1, 2 minus 2, 0, 4 minus 2 plus 2. Plus 1 minus 1 plus 2, answer is 2. Then here sigma x12, sigma CONC 10, 12 minus 10, again 2. Subtraction also separately you can do. No problem. Separately you can do. Right, you need to take a break. Only 2 more rules we are having. Shall we discuss these 2 rules and take a break? No, need the break. Right, if you want, you can take a break, and after that we can start. 2 more rules we have discussed. Rule 4 and rule 5. Okay, take a break, then we can meet. Yes. Calculator. I will show the number calculator. And rule 4. Says like this. If you take the summation of a power of variable, summation of a power of variable, sigma equals 1 to n xi power of summation of variable. Then you may think sigma I equals 1 to n xi power n. You may think here summation of a power of variable. You may think that is similar to power of summation of variable. That is not similar. Therefore, if you have to do sigma x squared, you should not do sigma x totally squared. That is wrong. Therefore, this is summation then power. This is first power then summation. Therefore, clearly you need to handle it. Otherwise, you are doing mistakes in the calculations. Instead of x squared summation, don't do sigma x totally squared. That is the rule 4. Now we write down in wording. Summation of a power of variable. Summation of a power of variable is not similar to the power of the summation of variable. Power of the summation of variable. Power of the summation of variable. Right. Then this rule. Take y equals 1 to n x squared x I power n. M is the power. Power 2, power 3, power 4, any power. Not similar. Okay, now practice this one. Sigma x squared. Now I am going to practice that. Take m 2, power 2. Then sigma equals 1 to n xi squared. Right? 2 squared. 3 squared. 1 squared. 2 squared. 4 squared. That is this part. 4, 9, 1, 4, 6, 8. 20, 29, 30, 34. 34. Then do this one. Sigma equals 1 to n xi total power 2 plus 3 plus 1 plus 2 plus 4. Then its power. What is the power? 4, 6, 9, 12, 14. 4, 5, 6, 8, 12, no? 12. 4, 6, 7, 10, 12. 12 is क्या? 144. Instead of 34, what would happen if you have calculated 144? That is a wrong calculation. 34 is not similar to 144. You need to clearly understand. Right, so far we discuss one variable, one constant, like 2 or more variables if you handle. Again, you won't practice. That's the rule 5. Now we study rule 1. Right, rule 5 says like this. You multiply 2 or more variables. Right? Summation of multiplication of variables. Not similar to first you multiply, first you take summation, then multiply. That is wrong. Therefore, we can write summation of the multiplication of two variables, xi, y. Right? Then you may think sigma I equals 1 to n xi, then multiply sigma I equals 1 to n yi. Multiplication of the summation of two variables. That is not similar. Therefore, if you have sigma xy, don't think that that is similar to sigma x, sigma y. No, it is wrong. They are not equal. Practice, right? Clearly understand, then you are not doing mistakes. At rule 5, we write down summation of the multiplication of two variables is not similar to multiplication of the summation of two variables separately. That's the rule. Sigma I equals 1 to n xi yi not equal. Sigma x, sigma y. A multiplication sign, even though you have written or not, that is multiplication. Now let's practice sigma I equals 1 to n xi yi. Right, first I multiply first observation with first. Second by second. 1 into 2. 2 into 4. 4 into 1. You multiply. Then plus 6. 3 into 2, 6. 2. 2 into 4, 8. 4 into 1, 4. 8, 10, 20, 26. Separately do. Sigma I equals 1 to n xi. 2 plus 3 plus 1 plus 2 plus 4. 4, 6, 7, 10, 12. Sigma I equals 1 to n yi. 3 plus 2 plus 2 plus 4 plus 1. 3, 5, 7, 8, again 12, no? 3, 5, 7, 8, 12. Right, then 12 into 12, and 40. Therefore, instead of 26, if I have calculated 144, wrong calculation. Wrong calculation. Right, clearly understand these sigma rules. Otherwise, you are going to simplify the formula. Without understanding sigma rules, if you simplify, then what happens? Finally, sometimes formula is disappearing. We cannot see a formula at the end. You have simplified, right? It will happen because that is a wrong simplification. Simplification is wrong. Time formula it may be sigma f x over sigma f. And you think that right, sigma f set off. Balance x. Without understanding sigma rules you have done. That's why. Formula එක සුළු කරගෙන ගිහිල්ලා formula එක නැති වෙලා යනවා. Right? You are simplifying the formula, finally, no formula. What happened? You cannot understand what happened to the formula. You are simplified. Therefore, practice these sigma rules correctly, then you are not doing any mistakes. Right. To practice, I will give one exercise. You have to justify, you have to prove it. Any more problem, we can start the analysis part. Right, here example x, y, c constant 3, x 2, 4, x and 1, y 3, 3, 2 and 4. Right. So that you have to solve penalty. Sigma I equals 1 to n 3xi equals 3 sigma I equals 1 to n xi. Second one, sigma I equals 1 to n yi squared not equal sigma I equals 1 to n yi not less than. Only three last one. Sigma I equals 1 to n xi yi not equal sigma I equals 1 to n xi sigma I equals 1 to n y. Right, within 5 minutes practice. First one, sigma I equals 1 to n cxi. Is 3 constant x2. 3 into 4. 3 into 6. 3 into 1. 6, 12, 18, 3. Answer. Answer 18, 20, 30, 36, 39. 18, 12, 13, 30, 36, 39. Then sigma, C sigma I equals 1 to n xi. Here, C is constant 3 multiplied 2 plus 4 plus 6 plus 1, 6, 10, 12, 30 into 3, 39. Then equal. Then you can say sigma I equals 1 to n Cxi equals C sigma I equals 1 to n xi. 39 equals 39. Right, second part, sigma I equals 1 to n yi. Y, 3 square, 3 square, 2 square, 4 square. 3 square, 9, 9, 4, 16. 16, 20, 20 times are 38. 38. The next one, sigma I equals 1 to n yi totally square. Y 3 plus 3 plus 2 plus 4 plus square. 4, 6, 9, 12, 12 square 144. Then 38 not equal 140. Therefore, this happens. Second, it happens. Like that, simplify and you can solve the problem. Right, then practice part 3. Sigma I equals 1 to n xi yi. 2 into 3. Second observation, 4 into 3. Fourth, 6 into 2. Third one. Fourth one, 1 into 4. 1, 1, 2, 2, 3, 3, 4, 4. 6, 12, 12, 4. Right, 12, 24, 32. Right, then separately multiply. Sigma equals 1 to n xi. 2 plus 4 plus 6 plus 1. 6, 10, 30. Then sigma I equals 1 to n yi. 3 plus 3 plus 2 plus 4. 6, 10, 12. Right, then 13 multiplied by 12. 36, 3 left, 12, 15, 156. Then instead of 34, I can't use 156, not equal. Clear? Right, then practice. Sigma rules you have to keep in mind. In practice, then you will become familiar. No mistakes you will do if you have done, if you learn sigma notation correctly. Okay, then we can start the analysis. When you start the analysis, first you want to start descriptive statistics totally, then we want to move to inferential statistics. Right, then we take main heading descriptive statistics. Descriptive statistics. Vistaratmaka Sankhya. Descriptive statistics. Descriptive statistics. Right, what is meant by descriptive statistic? We learn. In the introduction part, I mentioned classification of statistics. Descriptive, to understand the nature of data, we collect, organize, analyze, and present the data. Therefore, descriptive statistic, to understand the nature of data, all the calculations we do. Right? What are the measures? Measure of central tendency, measure of dispersion, measure of skewness, measure of vertices. You have noted down. You have noted down. Right? After I gave these four: central tendency, dispersion of variance, skewness, vertices. If you learn these four, you are fully aware of descriptive statistics. Only to understand the nature of data in your research, if you want to understand the nature of employee responses, customer attraction, labor turnover, whatever it is, the variable nature you study using descriptive statistics. But all these descriptive statistics you want to apply in inferential part. Hypothesis test, estimation, regression, correlation analysis, all these descriptive statistics, those calculations are required to test them. Here, understand the nature of data only. දත්තවල ස්වභාවය අඳුනා ගන්න you do the calculation to understand nature of data. Okay, right. Now we write down descriptive statistic. If we do the calculations, to understand the nature, within bracket level, matter, to understand the nature, within bracket level of data, descriptive statistics are applied. Descriptive statistics are applied. Descriptive statistics are applied. Following measures belong to descriptive statistics. Following measures belong to descriptive statistics. Right, at the moment, that knowledge you are having, because in the introduction part I have given measure of central tendency. Second, measure of dispersion. Otherwise variance. Measure of skewness. Measure of vertices. Measure of vertices. These four. Right. One by one we want to learn. Now take measure of central tendency. Measure of central tendency. Measure of central tendency. കേന്ദ്രിക പ്രവണതാവിനും കേന്ദ്രിക പ്രവണത. Measure of central tendency. What is meant by measure of central tendency? Right? I delete others, then measure of central tendency I keep. When you are collecting your data, you are having data. But keeping all these data, you can't take a good decision. Data will. Thousands days production, sales income, and annual customer visiting your supermarket, you are having data. But if you are having data, you can't take decisions to represent all these measures, to represent all these data. You need to calculate individual measurements. Individual measurements. When you calculate to represent all these data, one measurement, then you can take decision based on that. Therefore, these individual measures are called central tendency. Measures of central tendency. To represent all the data, you calculate individual measurements. These measures are called measures of central tendency. We use mean. Mean, simple mean, weighted mean. Mode, median, harmonic mean, geometric mean. These calculations belong to measures of central tendency. Understood? Right. First we write down like this. If we calculate individual measurements, to represent the total set of observations, they are called measures of central tendency. They are called measures of central tendency. These measures are given below. First one, mean. Simple mean, weighted mean. Second, mode. In histogram we mark that value. Median. In Ogilvy we mark that median. Harmonic mean. Geometric mean. These values, if you calculate, you understand measures of central tendency. To represent entire data set individual measurements. මුළු දත්ත ව්‍යාප්තියක් නියෝජනය කරන්න එක් විදිහට. Then you can take better decisions. Right, first we take simple mean. Simple mean. Simple mean, the idea of simple mean, that is the average. Number of total observation, summation of observation. That is the total divided by number of observations. Summation of observation sigma x divided by number of observation, that is simple mean, average. If the variable is x bar, that is simple mean, simple mean. If the variable y bar. Right. Now we write down like this. Simple mean. This is the average value. This is the average value. Summation of observations. Summation of observations is divided by the number of observations. Divided by the number of observations. If the variable is x, simple mean is denoted by x bar. Right, when you are calculating simple mean, you need to calculate set of observation as well as group frequency distribution. Both you need to calculate. Simple mean, mode, median, you need to calculate. Other measures for different purposes. Right, then we take subheading under that, simple mean in a set of observations. 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 Right, what is the formula? Summation of observation divided by n. Right, then we write formula x bar equals sigma x divided by n. Sigma x divided by n. That's the formula for set of observations. Sigma x over n. Right, example write down. Calculate simple mean of 3, 2, 6, 5 and 4. 3, 2, 6, 5 and 4. Right, now I calculate x bar. Sigma x means 3 plus, 2 plus, 6 plus, 5 plus 4. Divided by n, number of observation. 1, 2, 3, 4, 5. Right, 5, 10, 16, 20. 20 divided by 5, answer is 4. To represent all these observations, one value, best of center tendency 4. And right, how we can calculate in a group frequency distribution? Right. Then under that, simple mean in a group frequency distribution. Will mean, right? Simple mean. Simple mean in a group frequency distribution. Simple mean in a group frequency distribution. You know, classes there, 2029 or 2030, 30, 40, like that classes. Therefore, we consider mid value as x, mid value, class mark. First calculate mid value as x, then apply for. Otherwise, keeping Class range you can't calculate. You take mid value. Then write down. We calculate mid value. We calculate mid value of each class. Of each class. Each class. And they are considered as X. And they are considered as X. After that, following formulae can be applied. Following formulae can be applied to calculate simple mean. X bar sigma f x over sigma f. That formula you can use. Another formula there, A plus sigma fd over sigma f formula. This formula also can be used. Practice both, then finally practice this one to be applied, because small numbers you can handle here large numbers, but finally same answer. This is called assume mean method. Assume mean method. Upakalpita madhyana krama. Assume mean method. I think that you might have done this formula in O level. Isn't it? But O level means a very small thing you learn. But this formula, I think that you have learned. Right. We need to practice. We need to practice. We take our class and the frequency 2029, 3039. We calculate 4049, 5059, 6069, 7079, 8089. You said 3, the second one 5, no? 5. After that 7. 7, 8, and you said 10. 10. After that it's 5 plus 4 also 5. Then 40. This 40 is sigma, how do you know? Summation of frequency. Right. First we apply this formula. Now calculate mid value. Mid value. 36. 2029 mid value, how to calculate? We know in data organization form. You can take gap 9 divided by 2, 4.5 and to lower limit, or subtract from upper limit. Otherwise, 20 plus 29 added divided by 2. Whatever you can take 24.5. But this is easy. 24.5. Right. 30 means 34.5. 44.5. 54.5. 64.5. 74.5. 84. You know how to calculate mid value, class mark. Then sigma rules you are aware. Sigma fx means prior to sigma, f should be multiplied by x. Another column, x multiplied by x. Multiply. 3 into 24.5. 3 into 5, 15. 1 left. 12, 30. 1 left. 6, 7, 70.5. 20 to 2022 to left 15, 70, 172. By 7, 35, 3 left, 28, 31, 3 left, 28, 31, 311.5, 545, 0. 630, 3 left, then 24, 27, 2 left, 36, 38. 5, 5, 25, 2 left, 20, 22, 2 left, 35, 37. 20, 2 left, 16, 18, 1 left, 32, 33. Now take the summation of that. Sigma fx 5, 10, 15. Here 25, 20, 30, 30. Right, what is the summation? 5, 10, 15, 20, 2 left, 10, 10, 17, 19, 20, 25, 27, 28, 29, 30, 21, 25, 26, 30, two thousand 200. Correct? Right. Right. Then 2200 divided by 40 by 55. X bar 55. X bar 55. Right. For the addition, subtraction, all these, no problem. Scientific calculators you can use. The scientific calculators, FX 100 MS calculator is there. OFX 991 MS calculator is there. 991 ES calculator. 991 EX calculator. Different calculators there. But same thing, you can do all these calculators. But this is advanced than 100. 991 is advanced this one. EX is advanced ES. When you are doing the calculations, you need to practice scientific calculators. You should have the good knowledge of normally dead mode. Dead mode, normally you do your calculations, that is addition, subtraction, multiplication, and permutation, combinations, factorials, all these you do by using DEG modes. Then there is another mode, SD mode. That is for the descriptive statistic part, SD modules. Then there is another one, equation mode, EQN mode. That is for equations, simultaneous equations, quadratic equation, cubic equations. Especially we are applying simultaneous equations. Then RVG mode. RVG mode. That is for the regression correlation analysis. You need to practice all these modes. You have good knowledge about these modes. Knowledge right. Otherwise, at the same time, by taking some time, I discuss these modes as well. It's okay, no? Take a mode kata. Okay. Right. Whatever the calculators you are having, keep it. No problem. I will discuss all these calculators if you are having. Irrespective of the calculator, you can do all these calculations. Only the process is different. Right. Later, when you practice your statistical package, then you can understand same answers. Whatever you calculate manually, they can be obtained by statistical packages. Right, SPSS, CView, SysData, Minitab, SAS, whatever the programs, AMOS. Right. Then calculate by using second formula. Second formula. X bar A plus sigma D over sigma. This is the second formula. Here, right, in this formula, that's called assume mean method. Assume mean method. Right, mid value of any class. Mid value of any class you can assume as the mean. Assume mid value of any class you can assume mean A. Then you calculate deviation x minus A. Positive, negative, both there may be. Positive, negative, and zero. How far x values are deviating from A, that is called deviation. Then apply this formula. This is the way. Right under that, write down like this. Mid value of any class, can be assumed as the mean. That is denoted by A. Then we calculate deviation. Appagamani, deviation. That is by D equals x minus A. That is by D equals x minus A. After that, apply the formula. Right, again, write down this one. Class, frequency, and bit values. Class, frequency, and bit value. Okay. Any class mid value you can consider. If you are willing to use this one, no problem. Whatever, any mid value you can use. Like in general, highest frequency is what? This is 10. I consider this one. If you want, you take this one. No problem. Right, then calculate D. D means x minus a. X minus a. X minus a. Start from this one. X 54.5. A also 54.5. Then what happened? 54.5, 54.5, it will become 0. Right, then 44.5 minus 54.5, it becomes minus 10. 34.5 minus 54.5 minus 20. Then minus 30 from the class B. It goes like that. 64.5 minus 54.5 plus 10 plus 20 plus 30, like that you can see. If anybody started 64.5 as A, this will become 0, minus 10, minus 20, minus 30, minus 40. This one plus 10 plus 20. No problem. Finally, answer you can take same answer. That is D. Then in the formula, A 54.5, D there, before taking sigma, multiply F and D. Otherwise, you are violating sigma rules. Multiply F and D. 3 into minus 30 minus 90, minus 100, minus 70, 0, 60, 100, point to 30, 120. Then take sigma F. Sigma F. Right, negative values I take 0, 6, minus 260, plus value 0, 8 to 80, then balance is 20. Whatever the value, negative or positive, no problem. Take higher positive means plus 20. Then apply formula. A 54.5. Sigma FD plus 20. Sigma F 40. 54.5, 0.5. Then 55. Gain x bar 55. Irrespective of the formula, you can take same answer 55. Right. At the end, you can practice this question, right? This question at the end you can practice. Any clarification? Simple mean you can calculate like that. Right, then we are moving to weighted mean. Weighted mean. Weighted mean. Weighted mean. Weighted. Varatabu madhye. Weighted. Varita madhye. Weighted. X bar W. This is important if the intensity or the importance of the data is different. Simple means just we don't consider this part is important rather than this, not like that. If the observations or the variable data point importance is different, we want to calculate weighted mean. Most important variable high weight, less important variable less weight, like that. because the data point is different. When the employees are recruited, we do this one, wait at me. What is the section? I want to recruit an employee to human resource department. Then I consider the knowledge of human resource management. Therefore, human resource knowledge, high weight. Then maybe organizational behavior, weight. Or statistical or mathematical calculation, less weight. But to the research division, if you recruit employee, high weight to statistics, mathematics, those subjects. According to the importance, the data points you give different weights. After keeping weight, you calculate mean. That is called weighted mean, denoted by x bar w. X bar w. Right. First we write down, then we can start calculations. If the importance of data points, if the importance of data point is different, if the importance of data point is different, we calculate weighted mean. We calculate weighted mean. Most important data point is assigned high weight, Less important data point is assigned less weight, After assigning weight, average is calculated. That is called weighted mean. Denoted by x bar w. As an example, when we recruit employees, we consider their subject knowledge. And assign different weights. Weight should be determined by the management. If employees are recruited to HRM department, management subjects are important. If employees are recruited to research division, statistical knowledge is important. statistical knowledge is important. Formula is given below. Formula is given below. X bar W sigma equals 1 to n x times W1 divided by sigma I equals 1 to n W1. If I expand this, we might think x1 multiplied by W1, x2 multiplied by W2, like that, dot line, xn multiplied by Wn, divided by W1, W2, like Wn. Each data point is multiplied by corresponding weight. That's the thing. Example right now. Example. Calculate weighted mean of 3, 5, and 2. 3, 5, and 2. 3, 5, and 2. Assigning weight 3 to 2 to 1. 3 to 2 to 1. Respectively. 3 to 2 to 1 respectively. X bar W 3 multiplied by corresponding weight 3. Second data point 5 multiplied by 2. 2 multiplied by 1. Divided by weight 3 plus 2 plus 1. 9, 10, 2, 3, 5, 6. Then 19, 21 divided by 6. Then 3, 18. 18, 20, 18, 20, 21, 3 means 35, 3.5. Right? 3.5. Okay, answer 3.5. Okay, another exercise right now. Management of a company needs to recruit the most appropriate person to the research division. Two candidates have applied to the post. They have obtained following marks. To the three subject areas. Right here, candidate A and B. These are subjects. Statistics, mathematics, HR. Right here, 90 marks, 80 marks. Here, 70, 75. Here, human resource management, 60. Here, 90. Right, under that write down. According to the importance, according to the importance of subject knowledge, subject knowledge, subject knowledge. Management has weighted them. Management has weighted them 5 to 3 to 2 respectively. 5 to 3 to 2 respectively. Select the appropriate person. Select the appropriate person to the research division. To the research division. To the research division. Right, now you calculate X bar W of A. Right, first calculate. Right, X bar W, I calculate 90 multiplied by corresponding weight 5, 70 corresponding weight 3, 60 corresponding weight 2. Divided by 5, 8, 10. Otherwise, I can write 5 plus 3 plus 2. Right, 450 to 110, 120. Okay. 0, 5, 6, 8, 4, 6, 7. 78. Right, then calculate X bar W of P. Right, X bar W 80 multiplied by 5, 75 multiplied by 3, 90 multiplied by 2. 5 plus 3 plus 2. Zero 40. 15, 21, 22, 100 divided by 10. Here 5, 8, 10, 1 left, 4, 6, 7, 8, 6, 7, 8. 5, 8, 10, 1 left, 2, 4, 8 divided by 10. 80.1. Right, then you can decide 80.5, 78, right, put B. That's the decision. Then you can say recruit B, appropriate person B. Using weighted mean you decide. Weighted. On the importance. At this weight, sometimes you can change on the importance. Sometimes this HRM may be less than this. 5 to 3 to 1 maybe sometimes. It may be different. The management should decide that. Right, weighted mean you calculate if the importance of data is different. Otherwise, go for simple mean. Simple mean. Right, then we can start mode. Right, mode next week. Next week mode. Next week holiday. Right, the following week is start. 24, 25, Christmas holiday, no? Right, okay.